Hello, 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 everybody, and welcome back. We're looking at question number 15 on the Fermat paper. That's the grade 11 multiple choice contest from the year 2001. So what's question 15 got to say? A circle is tangent to the y-axis at 0, 2, and the larger of its x-intercepts is 8. So you can see we have 8 and 0 down here. The radius of the circle is, okay, so we're just given a couple points on the circle. Now, usually 2 points is not enough to determine a circle, usually. But we're given an extra special piece of information. We're not just given any 2 points. One of our points, 0, 2, happens to be a tangent, and that should give us enough information. Because one of the nice things about circles is that at when they hit their point, their tangent line, at that point, if you draw from the tangent line and the point at the circle and you draw outwards towards the center, you will have a right angle there. And so that right angle should give us just enough information to finish this question off. Okay, so as always, let's grab a piece of paper and redraw our picture so we can mark it up and then see what we can see. So I'll draw my circle first, and then I'll draw the axes in. Oh, that's an awful circle. I feel bad about that circle. That's also a pretty crummy circle, but I think I'll go with it. One thing I wish this program had was a nice way to draw a good circle. Alright, so we have our point of tangency here, and it was also the y-intercept. And then we have 8 and 0 down here, and it's the bigger of the x-intercepts. So this one down here, it looks like it would probably be 1, 0 or 2, 0 or something like that. Okay. So as I say, if we connect the center of the circle, which we don't know where it is, but if we connect the center of the circle up to its point of tangency, that makes a right angle with the tangent line. Since we have a right angle here, and we have a right angle here between our axes, we can tell that this line, this radius here, is parallel to the x-axis, which means that this center has coordinates of something 2. We're going to call that x. Okay? In fact, you know what? We're not even going to call it x. We're going to call it R2 because it happens to also be the radius. Because we move from 0 over to r, so that's the total distance we've gone here. So we're going to say we have a radius of r. Okay. So that's pretty good. So we almost have the center. And then we have another radius we can drop right here. And that's also r. And we know that from r2 to 8 and 0, should be the same distance as our radius here. Okay. Well, we can figure out the distance between 2 points on the plane, and we know what that distance should be, so we should get a single equation, probably a quadratic, in terms of r, and then we will use the quadratic formula, and we'll probably get 2 solutions for r. Usually when you use the quadratic formula on a quadratic equation, a second-degree polynomial, you will get 2 solutions out. Sometimes you can get no solutions, sometimes you can get only 1 solution. But I suspect we'll get 2 solutions. And the reason is, when we read the question again, we are told that 8, 0 is the sort of the biggest of the x-intercepts, which means that they're trying to narrow something down for us. So I think we'd get two possible values of r, one of which would have 8, 0 not be the biggest of the intercepts. So we're going to have to work that out, work out which the other intercept is, depending on which r value we've got. Okay? So that's just something to keep in mind, but that's where we're going with this. Let's get a quadratic in terms of r. So we can use the usual distance formula. So the distance between 2 points, which in this case we know is r, is the square root of the difference in their x-coordinates squared plus the difference in their y-coordinates squared. That's r minus 8 squared plus 2 squared. Well, we can square both sides. Get rid of that pesky square root sign. So we have r squared is r minus 8 squared plus 4. We can expand the r minus 8 squared. You can either FOIL it out or use the binomial theorem, however you want to do it. So r squared minus 16r plus 64 plus 4. And we can clean that up ever so slightly. Okay. So r squared is equal to r squared minus 16r plus 68. Well, actually, these r squareds are going to cancel one another out. So it looks like my intuition was wrong there. We aren't going to be solving a quadratic. We can bring this minus 16r to the other side. We should get a radius of 68 over 16. Now, both of those have a factor of 4. So that's 17 over 4. So it looks like our radius is going to be 17 over 4, and we didn't actually get two possibilities out here. That's interesting. Very interesting. Well, let's just double check and make sure we do have a smaller radius here. We should, because r here is less than 8, so we're definitely getting bigger. But, so our equation for our circle should therefore be x minus r squared plus y minus 2 squared is equal to r squared. So x minus 17 over 4 squared plus y minus 2 squared is equal to 17 over 4 squared. So that's 289 over 16. Okay. So I'll just double check, is 0, 2 on this? Well, yeah, if I plug in 0 here, I'll get 17 over 4, which I square. And if I plug in 2, I will get 2 minus 2 is 0, so 0 squared. 17 over 4 squared is equal to 17 over 4 squared, so that one's fine. How about 8 and 0? I'll just grab my calculator and double check that one. So 8 minus 17 over 4, and then I will square that, plus 0 minus 2, so that squared is 4. And it looks like that works out as well. Is there a way to tell what our other intercept is? So y would have to be 0 again. So we'll do 289 over 16 minus 4. Square root that. And this time we will take the negative of that and add on 17 over 4. So it looks like 1/2 0. Is the other x-intercept. Okay. Now we didn't need that. That was just me checking to make sure that the way I solved it didn't give 8, 0 as the smaller of the two x-intercepts. So 1/2 0. Okay. So what was the question actually asking us for? We were asked for the radius of the circle, so that's going to be 17/4. So we can just take that, and we have our final answer of C. Okay, so this was just a little double check here. Okay, not a bad question. It certainly turned out that it was a different calculation that a different equation in R that popped out. 16R equals 68, but good question nonetheless. And yeah, that's about it. So that was question number 15. Join me in the very next video for question number 16. And as always, I'll see you guys then.